Welcome back to another episode of Tech Talk, where we dive into the fascinating world of technology and data systems. Today, we're focusing on an important concept in database management, leader-based replication. Whether you're an experienced developer or just starting out, understanding how databases maintain consistency and availability is crucial. So grab your headphones and let's explore the intricacies of replication together. To start, let's clarify what leader-based replication actually is. In essence, it's a method where one database node, known as the leader, takes care of all write operations, while one or more follower nodes replicate this data. This setup is designed to ensure that even if the leader fails, the system can keep running, although there might be some data loss if it's not configured correctly. One of the standout features of leader-based replication is the difference between synchronous and asynchronous replication. In a synchronous setup, at least one follower must confirm it has received the data before the leader can move forward with more operations. This guarantees that you have an up-to-date copy of the data on both the leader and at least one synchronous follower. However, if that synchronous follower becomes unavailable or slow, the system can switch to an asynchronous follower to keep things moving. This is often referred to as semi-synchronous replication. On the other hand, fully asynchronous replication allows the leader to continue processing writes, even if its followers are lagging behind. While this boosts performance, it does come with a risk. If the leader fails, any writes that haven't made it to the followers will be lost. This raises concerns about durability, ensuring that once a write is confirmed, it remains safe and intact. These trade-offs have sparked ongoing research and development in replication methods. One interesting approach is chain replication, successfully implemented in systems like Microsoft Azure Storage. This method aims to strike a balance between performance and data integrity, working to minimize data loss while still enabling efficient operations. Now, let's discuss how new followers are set up in a leader-follower architecture. When a new follower is introduced, it's essential to ensure it has an accurate copy of the leader's data. This typically involves taking a consistent snapshot of the leader's database without locking it down for writes. Most databases support this feature, which is crucial for backups. After taking the snapshot, it's copied to the new follower node, which then connects to the leader and requests all data changes that occurred since that snapshot. This requires the snapshot to be linked to a specific position in the leader's replication log. Once the follower processes these changes, it can catch up and continue receiving updates from the leader. Maintaining high availability is another vital aspect of leader-based replication. The objective is to keep the system running smoothly, even when individual nodes fail. For instance, if a follower crashes or loses connection, it can recover by referring to its log, which tracks the last transaction processed before the fault occurred. By reconnecting to the leader, it can request all the data changes that happened during its downtime. Now let's dive into what happens when the leader fails. The process of switching to a new leader is known as failover, and it can be executed either manually or automatically. In an automatic failover, the system first determines that the leader has failed, often using a timeout mechanism. If the leader doesn't respond within a set time frame, it's presumed dead. Next, the system needs to select a new leader, which can be done through an election process among the remaining replicas or appointed by a designated controller node. The best candidate is usually the replica with the most up-to-date data to minimize data loss. Once a new leader is chosen, the system must reconfigure itself so that clients direct their write requests to this new leader. However, complications can arise, especially in asynchronous replication scenarios. If the old leader rejoins the cluster after a new leader has been established, it may have unreplicated writes that could conflict with the new leader's data. The common solution is to discard these unreplicated writes, but this can violate clients' expectations of durability. Another challenge is the potential for a split brain scenario, where two nodes mistakenly believe they are both leaders. This can lead to data corruption if both accept rights without a conflict resolution mechanism. To prevent this, some systems implement a safety catch to shut down one of the nodes if a split brain situation is detected. Let's also touch on the technical aspects of how leader-based replication works under the hood. In the simplest cases, the leader logs every write request and sends that log to its followers. However, this approach has its limitations. For example, statements that involve non-deterministic functions, like fetching the current date or generating random numbers, can cause discrepancies across replicas. To tackle these issues, many systems have shifted to row-based replication, where every change to the data is logged in a manner that ensures consistency across all replicas. This approach minimizes the risk of discrepancies and is generally preferred in modern systems. In summary, leader-based replication is a complex yet essential concept in database management. It involves balancing performance, availability, and data integrity through various methods of replication. From synchronous to asynchronous setups, and from failover processes to the technicalities of logging writes, understanding these elements is crucial for anyone working with databases. So there you have it. We've navigated the intricate world of leader-based replication, exploring how it works, its benefits, and the challenges it presents. As technology continues to evolve, the importance of robust data management systems cannot be overstated. Whether you're developing applications, managing databases, or simply interested in tech, grasping these concepts will serve you well. Thanks for tuning in to this episode of Tech Talk. If you found this discussion helpful, don't forget to subscribe and share it with your fellow tech enthusiasts. Until next time, keep exploring the world of technology.